A very good evening to all of you. Welcome to another session of Madhav Sankar classes. And we are continuing with the Environment and Ecology session. This is the lecture 15 of the series. Okay. So in the previous class, we have completed the area up to biodiversity. And today we are starting a new section, especially, regarding climate. Okay. So today I intend to take very small, couple of chapters. One is regarding ocean acidification. The other one is regarding climate change, global warming and other such stuff. Okay, so today will be a shorter class compared to other days, hopefully. And without any further ado, let's just dive into it. But before that, please make sure to subscribe to this channel if you haven't already done that. Also, please share this video with your friends and make sure to like this video. Okay, so let's begin. Climate change. One second. All right, climate change. So before moving on, explaining what climate change is, it's very important to know what is climate. Correct. What exactly is climate? If on a very fine day, it's feeling very hot and warm, or say if it's very humid, would you say that the climate is very hot, or would you say that the climate is very humid? No. We say that the weather is warm, or say the weather is highly humid. Okay, so there is a clear difference between climate and weather, although a lot of people mistakenly use one for the other. They are not synonyms. Okay, so weather is basically a very short-term event. Climate is actually the long-term average of a region's weather events. Typically, say a span of 30 years or 35 years. Okay, if the weather conditions of an area is observed for around 30 to 35 years, then the long-term average that we calculate from that basically tells you the climate of that region. Okay, so this climate is not static. It keeps on changing. 100 years ago, it could have been something else. 1,000 years ago, it could have been entirely different. Correct. So climate also keeps changing, but it's very gradual than weather. Weather changes every day, or maybe within a day itself, it changes a couple of times. Okay, so that is what is climate. Now, what does this climate change exactly mean? Climate change means a change of climate which is attributed directly or indirectly to human activities. So the climate change can occur due to a lot of factors. It can occur both naturally or say because of human induced factors. But the changes that occur naturally are very gradual. Okay, it takes a very long time, and it happens anyway. Even without any kind of human interventions, it will happen anyway. But recently, we started using this terminology, climate change, in order to specifically point to the contributions of human beings. The human actions have, a huge potential or a huge impact in the climate change. It has started to accelerate climate change for the worse. Okay, so this climate change, is usually measured in the shifts in temperature, rainfall, snow, wind pattern, etc., etc. So over the past couple of decades, the world has witnessed rising of temperature. Okay, especially since the 1990s, every year is basically the hottest year. And up till today, 2016 has been the hottest year recorded ever in the world. 2016. Okay, and 2020 came very close to 2016, almost same as 2016. So the temperature is keeping on, rising. Obviously, this is due to some process, okay, something that is happening around us. And the scientists call this using a very special term known as global warming. Okay, so this temperature rise that is happening over the previous decades, which has started a century ago, is basically termed as global warming. According to the typical definition of global warming is an average increase in the temperature of the atmosphere near the Earth's surface and in the troposphere, which can contribute to changes in global climatic patterns. Global warming can occur for a variety of causes, both natural and human induced. In common usage, Global warming often refers to the warming that can occur as a result of increased emissions of greenhouse gases due to human activities. So global warming is again a process that can be, that can happen even without human intervention. There are a lot of gases in the world, in the nature that exist, which can actually contribute to global warming. But this term is very important because human beings or the human actions are the main reasons which has led to such paced increase in global warming. Okay, so basically the global warming, that terminology refers to the average increase in temperature in atmosphere, especially near the Earth's troposphere. Okay, so that small change in temperature, that rise in temperature is known as global warming. So if the temperature is increasing, what is the problem? I mean, who cares anyway? If the temperature goes up, you can deal with some more air conditioners, correct? Other than that, what exactly is the issue with global warming? There are a huge implications. Okay, there are huge number of implications associated with global warming. First of all, rise in sea level and changes in the rainfall patterns. When global warming is high or the temperature keeps on increasing, what will happen? The glaciers, the snow covered areas, etc. will start to melt. A lot of water in this world is locked away in the form of glaciers and ice sheets, correct? So these will start melting. Himalayas, other mountain ranges, polar regions. So these waters will start melting, and this will contribute to the rise in sea level, which means a lot of small island nations will submerge underwater. Have you heard about Kiribati? Kiribati Islands are one of the best examples of certain islands which recently submerged in the sea because of global warming. Kiribati. So the islanders had to buy some land in a different country and move to that area. This is not an issue just for island countries. For all nations which have a coastal line, the coastal line, a lot of that area went underwater because of global warming, and it is happening. It's a continuous process. Then changes in rainfall patterns. Yes, think about it. A lot of changes have happened as far as rainfall is concerned. In India also, we started to have, our monsoonal system has changed considerably. Sometimes there is too much rain. Sometimes there is no rain. Okay, even when the monsoons are supposed to be present, we feel as if there is no rain. Correct? Sometimes when the rains are not supposed to be there, we have torrential downpours. A lot of factors contribute to this, but global warming is one of the major reasons for this. Second one, increased likelihood of extreme events such as heat wave, flooding, hurricanes. Yes, I don't have to explain this. Consider India again. We have hurricanes, we have cyclones very often in Bay of Bengal. Okay, very occasional, randomly, okay, rarely in the Arabian Sea also. Correct? Recently, we had a cyclone in Odisha. I hope you have read about it in the newspaper. So what are the causes of these tropical cyclones? How much does this climate change affect tropical cyclones? Do study about it. It has a lot to do with your geography also. So please study how tropical cyclones are formed and what are the influences of temperature and moisture in a cyclone. Then, melting of ice caps and glaciers, already explained. Widespread vanishing of animal populations due to habitat loss, another issue. Habitat loss is a severe issue. A lot of greeneries have vanished from the earth because of global warming. Correct. Certain animals are not very good in adapting to temperature changes, especially aquatic animals. I told you in one of our previous classes that aquatic animals do not adapt too much well with high changes in their surroundings because water has a very high specific heat capacity. Correct? So it takes a lot of heat to change the water temperature. So usually the external ecosystem of an aquatic animal is more or less very stable compared to its internal system. But the problem is, due to the global warming and associated factors, external system also started to become very much unstabilized. And this has resulted in vanishing of a lot of species, lot of habitat, etc., etc. Plenty of species are also even in the verge of extinction because of climate change. Then spread of diseases, malaria and so and so. There are certain diseases, especially in the tropical regions, which favor a higher temperature for its spread. Example, malaria, mosquitoes. Okay, the breeding of mosquitoes are facilitated by stagnant water and a good temperature conditions. So such diseases will start to spread. Bleaching of coral reefs, yes, and loss of planktons. I have explained this point in one of the previous classes regarding aquatic ecosystem. How does temperature affect the coral reefs? We will look into that in depth in the upcoming slides. At that time, I will explain it better. But these are some of the impacts that global warming can have on Earth. This is not an exhaustive list. There are plenty more impacts. Okay, another term associated with global warming is greenhouse effect. What is this greenhouse effect? Have you heard about a greenhouse? Greenhouse is basically a kind of a nursery for plants. Correct? In temperate regions and in say very cold countries and all, plants cannot survive. Certain green plants cannot survive. So you make a glass dome kind of thing and put all your plants within that. Within this dome, the temperature will be higher than the outside temperature. So plants will be able to survive. So that is the basic idea of a greenhouse. Earth, because of the global warming, has actually become a greenhouse. Okay, a greenhouse effect. What exactly does this mean? Greenhouse effect is a naturally occurring phenomenon that blankets the Earth's lower atmosphere and warms it. This is actually a positive thing. You might think that greenhouse effect is very bad because of all the things that you hear from the news. But without greenhouse effect, the temperature on the Earth's surface would be minus 19 degrees Celsius, which means it will be inhabitable. It is the greenhouse effect that is making this planet habitable. The only problem is greenhouse effect should be at that range. It should not go beyond a particular range, particular threshold. But unfortunately, because of the human activities and because of all the greenhouse gases that we put into the environment and atmosphere, the greenhouse ability or the greenhouse effect has considerably increased. And this is causing global warming, and it is increasing the temperature on Earth's surface, resulting in all kinds of environmental issues. Okay, so how does this actually work? How does this greenhouse effect actually work? The prime source for energy on Earth is solar energy. Correct? Sun's radiation is the major source of energy. So solar energy is emitted at very high energy in shorter wavelengths, very short wavelengths. So this, because of the high energy, it penetrates through the Earth's atmosphere and comes all the way down to the troposphere. I mean, at least most of it. Some of them are reflected back by the clouds and all, but a considerable amount will finally reach the Earth's surface. Correct? Now, of all that has been reached, around 30% is actually reflected directly back into space, as I have mentioned earlier, by clouds and surface of the Earth, etc., etc. 30% is gone. Forget about it. The rest of the energy is actually absorbed by the Earth's system. Some of it is absorbed by green plants, some of it is absorbed by, say, other particles in the atmosphere, some of it is absorbed by the, water, sea surface and all, some of it is absorbed by the land. Okay, so 30% is gone, rest is absorbed. From all this absorbed energy, because Earth is cooler than the sun, some of this energy is actually emitted back by the Earth. Okay, so we get energy from the sun. Earth absorbs some energy already, and then some of this energy is actually emitted back by the Earth. These radiations are not as much intense as the ones coming from the sun. Okay, so these radiations are also of longer wavelengths. Longer wavelengths. The incoming radiations are shorter wavelengths. Okay, so these radiations, these longer wavelength radiations are known as terrestrial radiations. Okay, so these terrestrial wave radiations, because they are not having that much energy and because they are having a higher wavelength, these gets trapped within the Earth's atmosphere. Who traps this? This trapping is actually done by the greenhouse gases. Okay, greenhouse gases such as carbon dioxide and all other, chlorofluorocarbons and all these various methane and all such greenhouse gases traps these terrestrial radiations. Because these radiations does not have the energy to penetrate these gases and go out. Okay, and these are in the infrared range. The incoming radiations are around the ultraviolet spectrum, but the outgoing radiations, these reflected radiations, are in the infrared spectrum. Okay, so not that much energy to penetrate through the gas layer and go out. So these are the radiations which keep the Earth warm. Okay, the greenhouse gases trap these radiations and keeps the Earth warm. The only problem is what happens if the greenhouse gas amount is very, very high. Then a lot of terrestrial radiations are absorbed. Correct? The amount of terrestrial radiations absorbed keeps on increasing, which means the temperature also will keep on increasing. So we have to maintain the greenhouse gases in the atmosphere in an optimal level. But unfortunately, due to human actions such as burning of fossil fuels, deforestation, etc., the greenhouse content in the atmosphere has increased considerably, which is leading to rise in the surface temperature of Earth. Similarly, other global warming issues. So what are these greenhouse gases? I told you that the greenhouse gases basically trap the terrestrial radiations and keeps the Earth warm. So which are these gases? Does oxygen do that? No, oxygen is not a greenhouse gas. So what exactly are the greenhouse gases that are causing all these issues? The following are the greenhouse gases, the major greenhouse gases. First, starting with water vapor. Okay, water vapor is one of the biggest contributors to greenhouse effect. Without human intervention, water vapor content in the atmosphere is always there. Okay, even with or without human intervention, water vapor content will always be there. Correct? Because we have huge oceans, rivers, ponds, lakes, etc. And because of the evaporation, water vapor content will anyway be there. Correct. Then how is water vapor playing such an important role in the recent higher increase of global warming? This is because of human actions. Again, we are the issue. So what is this? What are the human activities that is causing more and more water vapor content in the atmosphere? Or is it how global warming is happening? Because of human activities, carbon dioxide level in the atmosphere keeps on increasing. Okay, like because of fossil fuels and all such burning of such things, carbon dioxide keeps on increasing. Carbon dioxide is a prominent greenhouse gas. This will increase the global temperature. Correct? And this added temperature, this increase in temperature will cause the rate of evaporation also to increase. Did you understand? Because human beings are putting more and more carbon dioxide and other greenhouse gases into the atmosphere and causing the global warming and rise in temperature, this rise in temperature causes even more evaporation, thereby adding more water vapor into the atmosphere, thereby even increasing the temperature, even more increasing the temperature. Correct? This is how water vapor causes global warming, or the accelerated global warming that has been happening in the recent periods. Correct. Without human activities, this accelerated global warming does not happen. Water vapor will rise up due to evaporation, then condense back and with precipitation and all and come back. Okay, that cycle, that water cycle, hydrological cycle will go on as usual. But the rate of this cycle is much more accelerated because of the increase in temperature facilitated by other gases, which are because of the human activities. Okay, second one is carbon dioxide. The major issue. Carbon dioxide is the primary greenhouse gas emitted through human activities. This is the major issue. Okay, even without human activities, there is a very small quantity of carbon dioxide present in the Earth's atmosphere. We already know that. But human-induced emissions result in more and more increase in this gas content. Correct. So changes in carbon dioxide emissions from fossil fuels, etc., are influenced by many factors, including population growth, economic growth, change in energy prices, new technologies, changing behavior. Okay, so all these things facilitate the more and more input of carbon dioxide into the Earth's atmosphere. So this is the one of the major causes of global warming. The carbon dioxide is one of the major global warming gases, greenhouse gases. How can we reduce the carbon dioxide content in the atmosphere? The most effective method to reduce carbon dioxide emissions is basically to reduce fossil fuel consumption. Okay, reduce the exploitation of fossil fuels and go for alternative sources of energy, which are renewable and non-conventional, such as solar energy, wind energy. That is the only way to reduce carbon dioxide from Earth's atmosphere. Also, forestation. Okay, stop deforestation and start more and more forestation activities. So this is another issue, another major gas. Third one is methane. So how is methane present in the atmosphere? Methane is a gas which occurs naturally, but again, human activities has contributed to the increase in methane in the atmosphere. But how does it actually contribute to global warming, or what are the major sources of methane? The main natural source of methane is wetland. We have studied about wetlands in the previous chapter. I hope you remember. Wetlands are one of the most productive regions in the world, but also it has a lot of features that emits methane. Okay, why? Because wetlands are also areas where a lot of decomposition happens. Bacteria and other microorganisms decompose a lot of things in these wetlands, correct? And decomposition activity results in production of methane. Okay, so wetlands are the biggest natural sources of methane in the world. And then obviously human activities because of a lot of other things. Major one is agriculture. Agriculture is the single primary human source that causes maximum methane emission. During agriculture, we use all sorts of fertilizers, correct, into the farmland and all. This will result in production of methane. Similarly, livestock farming, cattle, buffalo, sheep, goat, such animals, they all produce a lot of methane during their digestive processes. So agriculture is the single human activity that produces the most amount of methane, contributing to the global warming. Then there are some industrial effects also. Methane production. Methane is a product along with the natural gas in industrial processes. Okay. Similarly, waste disposal. When you dispose of wastes in landfills and all, what happens? Again, even if that landfill is properly covered and all, still due to the decompositional activities, due to the bacterial and anaerobic decomposition and all, methane is produced as one of the byproducts, CH4. So these are the main contributors of, or the sources of, methane into the Earth's atmosphere. Okay, so natural sources are not just wetlands. Wetlands is the major source. Other minor sources include, say, oceans, sediments, volcanoes, wildfires, etc., etc. But these are very minor. Okay, wildfires does not happen every day. It happens whenever it happens, but that can be compensated in the cooling period. Okay, say again for volcanoes, volcanic eruption does not happen every day. It happens occasionally, but again after there is a considerable gap between two volcanic eruptions, so there is enough time to bring all the methane back in various forms back into the Earth's crust. It is the human activities that does not have that stability, that does not have that kind of compensation, which causes more and more methane to be present in the Earth's atmosphere. Then comes nitrous oxide. Okay, a lot of oxides of nitrogen, mainly nitrous oxide. Nitrous oxide is again present naturally in Earth's atmosphere because of the Earth's nitrogen cycle. I hope you remember my class on nitrogen cycle. Nitrous oxide, I have talked about various oxides of nitrogen at that time, ammonia, nitrogen dioxide, nitric oxide, etc., etc., all those things. How acid rain is formed. I hope you remember all that. But anyway, nitrous oxide is naturally present in Earth's atmosphere. Human activities such as agriculture, fossil fuel combustion, wastewater management, etc., also contribute to nitrous oxide concentration in Earth's atmosphere. Again, nitrous oxide is emitted due to bacterial actions while in the soil and all. You have heard about nitrogen fixation bacteria and all, right? So there are certain bacteria present in the soil that are capable of breaking down nitrogen. This also causes emission of nitrogen dioxide. Nitrous oxide. Nitrous oxide is emitted when people add nitrogen to the soil through use of synthetic fertilizers. Yes, NPK, nitrogen, phosphorus, and potassium. So nitrogen is one of the major components of fertilizers, all fertilizers. So adding more nitrogen will facilitate the production of nitrous oxide. Nitrous oxide is again produced through vehicular exhausts. Okay, when transportation fuels are burned, when fossil fuels are burned, nitrous oxide is one of the side products. Industrial production. Then all these factors, put more and more nitrous oxide into the atmosphere. So how do we remove it? What is the removal or what is the mitigation measure? Nitrous oxide is removed from the atmosphere when it is absorbed by certain type of bacteria or destroyed by ultraviolet radiations or chemical reactions. So certain types of bacteria are capable of breaking this down. So that is one natural method of reducing or removing nitrous oxide from atmosphere. Another natural method is ultraviolet light. Ultraviolet light, because of its very high energy, has the potential to break down nitrous oxide. Third one is some natural chemical reactions. For example, nitrous oxide along with rainwater and all mixed to form HNO3, that is nitric acid. This will come down as acid rain, but it will anyway reduce the concentration of nitrous oxide in the atmosphere. Although acid rain is very, very dangerous for the habitation. Okay, so this is about nitrous oxide. Then comes fluorinated gases. So what are the major fluorinated gases? You have heard about ozone depleting substances, right? Earlier, when the ozone hole, etc., came into the news for the first time, and scientists started to study about it more and more, they found that chlorofluorocarbons, or the CFCs, which are used as refrigerants and all, were the primary causes of this. Okay, so these are ozone depleting substances. We will study about that in the next class. But anyway, fluorinated gases are something very, very, very much similar to CFCs. Okay, these are emitted through a variety of industrial processes such as aluminum and semiconductor manufacturing and etc. for substitution of ozone depleting substances. So in order to remove CFCs from our daily use to prevent the ozone hole from enlarging, we have substituted CFCs with fluorinated gases. Okay, instead of CFCs, use fluorinated gases. Only problem is fluorinated gases may not be an ozone depleting substance, but they have a very high global warming potential. Okay, they may not destroy ozone layer, but they have a very high global warming potential, which means they can induce severe global warming. So fluorinated gases are removed from the atmosphere only when they are destroyed by sunlight in the uppermost layers of atmosphere, which means fluorinated gases are the most potent and longest lasting type of greenhouse gas emitted by human activities. Okay, for carbon dioxide, we studied how we can eliminate it or remove it from the atmosphere. For nitrous oxide and all, even natural processes can easily eliminate it. But fluorinated gases can only be eliminated when they are exposed to sunlight at very high, areas of atmosphere, which means they will last in the atmosphere for a very, very, very long time. Okay, so they have a long lasting effect compared to other greenhouse gases. There are three main categories of fluorinated gases. They are hydrofluorocarbons, HFCs, perfluorocarbons, PFCs, and sulfur hexafluoride, SF6. These are the three major categories of fluorinated gases. Okay, so hydrofluorocarbons are used as refrigerants, aerosol propellants, solvents, etc., etc. Similarly, perfluorocarbons are used as in various industrial processes associated with production of aluminum, semiconductors, and so on. Sulfur hexafluoride is used in electrical transmission equipments and etc., etc. So these are all very, very useful things, but unfortunately, the cost is the environmental cost is very, very high. Okay, so replacing CFCs with HFCs was not exactly a bright idea. So now we are trying to remove the HFCs also by replacing it with something else. Okay, go search about Kigali meat. Okay, Google this. What happened in Kigali is a place in Rwanda. What happened in Kigali? Go search and find out how much is HFCs harmful to our environment. Now, black carbon. What is black carbon? Basically, black carbon is not a gas. It is a solid particle, or something like an aerosol. You know that the soot and all, which comes you when you burn things in your house and all. You have seen that, right? Very minute black particles that fly up along with the ash, commonly known as soot. This is the black carbon. Okay, so this is again a major pollutant. We have already looked into the pollution angle in our previous chapters. But how does this contribute to global warming? That is the question. Black carbon warms the earth by absorbing heat in the atmosphere and by reducing albedo. What is albedo? Albedo is the ability to reflect sunlight. Correct? So earlier I mentioned that around 30% of sun's energy is directly reflected back by the clouds and the glaciers and ice and all. Correct? This is known as albedo, the reflected back thing. But if black carbon is present in that region, this will considerably reduce the albedo. Why? Because this will absorb a lot of energy. This has the potential to do that. Especially in consider areas like glaciers or ice snow-covered areas. If black carbon is deposited over the snow which is an excellent repeller of sunlight, which can reflect the sunlight back, will lose its reflective capacity because the black carbon will absorb everything. Got it? So this is how black carbon contribute to global warming. Okay, and black carbon stays in the atmosphere for only several days to weeks. This is the advantage. Unlike say fluorinated gases or unlike carbon dioxide, black carbon does not have a long life. Black carbon stays in the atmosphere only for a few days to weeks, which means if we stop burning of all these substances, or if we can convert to better methods in disposing of the waste and find alternatives for burning, then we can actually reduce the content of black carbon in the atmosphere very, very quickly. It is easily reducible. That is the advantage. Government of India, in order to strive for this, has actually came up with a project named as Project Surya. Okay, global studies have said that around 30 to 35% of the black carbon in the world is actually contributed by India and China. Okay, especially because of our rural in development. In the rural areas, still we do not use LPGs or cleaner cooking fuels. Instead, wood and all are burnt, causing even more pollution and even more black carbon to be pushed into the atmosphere. So, Project Surya, launched by the government of India, has been launched to reduce black carbon in the atmosphere by introducing efficient stove technologies, solar cookers, solar lamps, biogas plants, etc. Alright, now just as black carbon, there is another thing known as brown carbon. What is brown carbon? Brown carbon is anything other than the black carbon, which can be in various forms such as soil humics, humic-like substances or hulis, Okay, then tarry materials from combustion, bioaerosols. So all these things, light absorbing organic matter in the atmosphere, okay, other than this black carbon, are all classified into brown carbon. Get it? This is also a very good absorber of heat, and hence it's contributed to the global warming factor. Now, climate forcings. So we have completed the major global warming gases in the atmosphere. Okay, so what exactly is climate forcings? This is another term we see a lot associated with climatology. So what exactly contributes or constitutes climate forcings? Factors in the climate system that either increase or decrease the effect to the climate system are known as climate forcings. Okay, any factor in the atmosphere, in the climate, that increases or decreases the effects to the climate, are known as climate forcings. So there are positive forcings and there are negative forcings. The positive forcings, such as excess greenhouse gases, warm the earth. Negative forcings, such as effects of aerosols, volcanic eruptions, etc., cools the earth. Okay, so those that increases the temperature on earth are known as positive forcings, and those that decreases the temperature is known as negative forcings. Clear? Greenhouse gases are all contributing to rise in temperature, so they are all positive forcings. Volcanic eruption, aerosol, all these actually decreases the temperature, so they are known as cooling or negative forcings. How does volcanic eruption decrease the temperature on earth? Any idea? You might have thought it otherwise, correct? You might have thought that because of all the soot and dust particles emitted, it might actually increase the temperature. But actually it's the other way. Presence of aerosols and volcanic eruptions, etc., actually cools down the Earth's atmosphere. How? Any idea? It's actually very simple. Aerosols that form naturally during volcanic eruptions cool the atmosphere. Large volcanic eruptions can eject enough ash into the atmosphere to lower temperature for a year or more until the sulfate particles settle out of the atmosphere. So this ash content emitted by the volcanic eruptions, they travel around the atmosphere for a very long time. It takes considerable amount of time to settle down. And these particles, these aerosols, which have a lot of sulfur content and all in it, can actually reflect off a lot of energy back into outer space, thereby increasing the albedo. Okay, that is how volcanic eruptions actually reduces the global temperature. Although we might think otherwise, it is a huge, pollution issue, but even then it can reduce global temperature. Understood? So dark carbon-rich particles such as soot from diesel engines and all, they all absorb the energy and they will increase the global warming. So these are all positive forcings. But exhaust from high sulfur coal or oil produce light aerosols, etc., they all reflect sunlight back into the space and produces cooling effect. Okay, so these are all negative forcings. Did you understand? Anything that increases the temperature is a positive forcing, and anything that decreases the temperature is a negative forcing. Okay. Welcome, Sunita Mishra. I did not understand what you are trying to say. Next one. Again, forcing, a general topic. The power of a process to alter the climate is estimated by its radiative forcing, the change in Earth's energy balance due to that process. Earlier I told you, it is basically the power of the process to alternate the climate on Earth. If it increases, if it has a positive impact, it is a positive forcing. If it has a negative potential or reducing the temperature, such similar activities, then it is a negative forcing. So natural forcings include changes in the amount of energy emitted by the sun, very slow variations in Earth's orbit, volcanic eruptions. These are all examples of natural forcings, those events which can increase or decrease the changes happening in the climate. Climate forcing can also be because of human activities. Okay, so the initial ones that I mentioned were natural, volcanic eruptions, changes in Earth's orbit, energy emitted by the sun. All these are natural. Humans does not have anything to do with that. But there are certain forcings which are induced by human activities also. These activities include greenhouse gases, aerosol emissions from burning fossil fuels, modifications of the land surface such as deforestation, etc. etc. These are also forcings. Some of these forcings are cooling, which means they are negative, and some of the forcings are positive, which means they will increase the temperature. Okay, now global warming potential. What exactly is global warming potential? We have already studied the term global warming, correct? What exactly is global warming potential? What does this phrase means? Global warming potential describes the impact of each gas on global warming. Okay, carbon dioxide is a global warming gas. It is a GHG, greenhouse gas. Methane is a greenhouse gas, which means it also has global warming potential. Correct? Chlorinated gases, again, another one. Water vapor, another one. But each of these gases have different potentials of global warming. Understood? So, global warming potential for a gas is a measure of the total energy that a gas absorbs over a particular period of time, usually 100 years. Okay, each gas, carbon dioxide or say methane, whatever it is, each absorbs different amounts of energy. Maybe carbon dioxide can absorb a lot of energy compared to another gas, but carbon dioxide may not absorb as much energy compared to say methane. Okay, so different gases have different measure of the total energy that they can absorb. This is basically defined as global warming potential. And global warming potentials of different gases are measured based on carbon dioxide. Carbon dioxide has been taken as the standard. Okay, why? Because carbon dioxide has a global warming potential of 1. So this is taken as a base value, and global warming potentials of other gases are measured based on that of carbon dioxide. Say for example methane. Consider methane. Methane has a global warming potential that is 20 times higher than CO2 for a 100-year time scale. Okay, so CH4 emitted today lasts for only 12 years in the atmosphere on an average. However, on a pound for pound basis, CH4 absorbs more energy than CO2, making its GWP higher. So methane is a gas which has a higher potential of global warming compared to carbon dioxide. So it varies for each and every gas. Please take a list of it. Find out which is the gas that has the maximum global warming potential, maximum greenhouse effect, and at least study the top 5. Okay, Google it. You can easily find out. I think you can find a lot of results. You can get the list as such. At least study the top 5. Top 5 greenhouse gases in the world having the highest global warming potentials. Okay. Now, receding glaciers, a symptom of global climate change. So in the recent past, especially in the previous 2 decades, glaciers all across the world started to reduce or break away. Okay, you might have heard that huge glaciers in the Antarctic region and Arctic region have all separated from the main body, or say all these has started melting or have collapsed. Correct. So these events has been witnessed in the past 2 decades in a higher frequency. Okay, so what is the impact of this glacial retreat? First of all, potential impact on water supplies. Glaciers are one of the biggest suppliers of fresh water in the world. Rivers such as Ganges, Yamuna, all emerge out of the Himalayan glaciers, correct? So if the glaciers are gone, then it could have severe effect on water supplies, especially in landlocked areas. Variation in both temperature and snowfall, causing changes in the mass balance of glacier, also correct. Glaciers provide a certain kind of ecosystem in its surroundings, but climatic changes can vary the temperature, snowfall, etc., destroying the alpine kind of ecosystems in the world. There will be a instability throughout that region. Glaciers provide critical water supplies to dry countries, The loss of these glaciers would have tremendous impact on ecosystem of that region. Serious threat to national and global economy and environment. That is also there. Water is one of the most important materials in the world. Correct. It is one of the fundamental things that human beings need to survive. In an economic sense also, water is very, very, very important. Correct. So any say threat to water will also be a threat to the economy of that country and the world as such. Finally, rise in the sea level. I explained this point at the beginning of this class. I hope you remember. Rising sea level causes a lot of areas to submerge underwater, forcing a lot of people to move from different parts of the world to somewhere else, which is known as migration. Okay, migration due to climate change is a severe issue. I hope you have read reports regarding that in the newspapers in the recent past. Haven't you heard about the girl named Greta Thunberg and all? She was in the news for a very long time. She still is, because of her activities in preventing these kinds of threats to the climate and all. Okay, so do look into all such current issues, because the questions that will come from this area will be based on current issues. I'm teaching you the static portion, which acts as a base for you to connect different points. All right, so that is the first topic of the day, that is climate change. Second topic is ocean acidification, which is a very small topic. We will finish it like 10 to 15 minutes. So what is ocean acidification? Oceans are important reservoirs of carbon dioxide. I hope you remember from our previous class. Oceans can both emit carbon dioxide and absorb carbon dioxide. That atmosphere-ocean boundary, is a constant exchange of gases. Okay, so carbon dioxide, ocean acts as a major sequestration of carbon dioxide. Clear? But over the years, because of the human activities and because of the higher amounts of carbon dioxide in the atmosphere, ocean acidification started to happen. What is ocean acidification? Ocean acidification is the change in ocean chemistry. Okay, basically lowering of ocean pH. What is the pH value of ocean? Ocean is basically alkaline. Okay, a lot of sodium chloride, basically an alkali. Okay, it's a basic substance, sodium chloride. So when it is dissolved, it becomes an alkali. So the pH of the ocean is around 8.0. It is basic in nature. But over the years, we have seen that because of the human-induced activities, the pH has started to decrease. It is still alkaline, it is still very much basic, but it has started to decrease. It's 7.9 and something like that, coming down, which means the ocean is actually slowly acidifying. Okay, it is still very much basic, but since it is coming down, we are calling it as acidification. It's not acidic in nature. It is acidifying. Got it? I hope you understood the difference. The pH is still very much basic, but because the pH is decreasing, we are calling that process as acidification. Okay, so what happens is, as the uptake of the atmospheric carbon dioxide by the ocean increases, the concentration of hydrogen ions in the ocean also increases. So this will facilitate a decrease in the concentration of carbonate ions. And this will result in the pH to decrease. Okay, when more and more carbon dioxide is absorbed by the ocean, what will happen? The hydrogen ions in the ocean will increase, which means it becomes more and more acidic. And correspondingly, the carbonate ions will keep on decreasing. This effectively decreases the pH of the ocean, making it less alkaline, and the process is known as acidification. What are the major factors? Acid rain, eutrophication. You know what acid rain is. Acid rain has a pH between 1 and 6, thanks to all the pollutions created by human beings, especially sulfur compounds, sulfur oxides and nitrogen oxides. Okay, so acid rain is basically nothing but sulfuric acid and nitric acid, having a pH between 1 and 6. So when this water is added into the ocean, it becomes acidic. But the good thing is, acid rain is very much local. It does not happen globally. It happens closer to industrial areas only. Okay, so that means the acidification happens in a very small area compared to the huge oceans. So not a major contributor to the ocean acidification. Second factor is much more evident, that is eutrophication. How does eutrophication contribute to ocean acidification? First of all, we are inputting all kinds of minerals, correct? Eutrophication means what? Basically, due to leaching and all, lot of minerals are finding their way into the oceans. Correct? Agricultural waste, fertilizers, sewage, etc. etc. So this eutrophication leads to the large plankton blooms, algal blooms and all. Correct? So when these blooms collapse, they sink to the bottom of the seas, and at the bottom they undergo decomposition by bacteria and algae and etc. So bacteria decomposes these algae and all. Correct? When this decomposition happens, what will happen? The dissolved oxygen content will decrease. I have already taught you this in previous classes, so that is why I am not taking too much time explaining all this. When this decomposition happens, it reduces the dissolved oxygen content. Correct? And this will increase CO2. Okay, when dissolved oxygen is reduced in the water, naturally it means carbon dioxide concentration is increased, which means pH value decreases. When carbon dioxide concentration increases, what will happen? Carbonic acid is produced, and carbonic acid is an acid. Okay, so having pH less than 7. So overall, the pH will come down, thereby acidifying the ocean. Now, effects of ocean acidification. Lots of effects. Most of it are very much logical. You can write it down yourself. But understand that seawater absorbs carbon dioxide to produce carbonic acid, H2CO3. Along with carbonic acid, some other things are also produced, such as bicarbonate and carbonate ions. Okay, HCO3 double minus and carbonate ions, that is CO3 2 minus. Okay, I'm sorry, it's not 32 minus, this CO3 and 2 minus as the something like this. Okay, so these carbonate ions are very much essential for calcification process that allows certain marine organisms to build their calcium carbonate shells and skeletons. We have studied about coral reefs. Okay, coral reefs are able to build these reefs because of the calcification process. And for calcification process, these carbonate ions are very important. Why? Because calcification means calcium carbonate. It is calcium carbonate, correct? CaCO3, that is the shell. Correct? So these carbonate ions are very important. But when ocean acidifies and more atmospheric carbon dioxide is absorbed by the ocean, this will increase the concentration of carbonic acid and the bicarbonate ions, and it will decrease the carbonate ions. Okay, when more and more CO2 is added into the ocean, the first two things, carbonic acid and bicarbonate ions, keeps on increasing, but carbonate ions keeps decreasing. All right, and this will cause severe issues with calcification process. The carbonate ions are less available and the calcification is therefore harder to achieve. Understood? So a lot of such animals which depends upon this reef building and all will die out. The only way to prevent this is reducing carbon dioxide content in the atmosphere and using alternate sources of energy which are cleaner and which are less which have less impact on environment and so and so. Use renewable energy, solar energy, wind energy, etc. etc. Okay, you have to understand or study one associated term with ocean acidification, that is saturation horizons. What is this saturation horizon? So the concept is actually very simple. Deep, cold ocean waters are naturally undersaturated. Okay, it's a single word, undersaturated with carbonate ions, causing the shells of most calcifying organisms to dissolve. So in the deepest of oceans, the water is extremely cold and they are undersaturated. Okay, the carbonate ions are very less there. So what happens is, if some calcifying things go down to these waters, they will immediately dissolve. Got it? Because there are the carbonate ions are already very less, so it is easier to dissolve. It is not saturated. Correct. Just think about it. If you have a bottle of water, clean water, plain water, and if you have another bottle of water which is saturated with sugar, a sugar solution, then you are adding more sugar to both these waters. What will happen? The sugar will dissolve quicker in the cleaner water compared to the sugar solution. Why? Because this is already very much saturated. Correct. So same goes for oceans. In the deepest of waters, where the water is very cool and all, the amount of carbonate ion is very less. So if carbonate ion or if any calcium carbonate compounds go into that region, it will immediately dissolve. Clear? But on the contrary, in the surface waters, in the shallow waters, carbonate concentration is very much high. It is oversaturated with carbonate ions. Okay, so here the carbonate ions do not immediately dissolve. That is how these organisms are able to build their reefs and all, because they do not dissolve away as quickly as in the deeper oceans. Understood? So this saturation, the saturation horizon, is basically the level below which calcium carbonate minerals undergo dissolution. Okay, so in the if this is the ocean, then this is that line, saturation horizon. Below this region, below this level, the calcium carbonate will immediately undergo dissolution, and above this, it does not dissolve as quickly as in the lower regions. That horizon, that separation mark, is known as saturation horizon. Okay, and because of the ocean acidification, this horizon started to rise vertically in the previous years. Okay, when more and more acidification, ocean acidification happens, this line, this saturation horizon started to come up. Okay, so what will happen when this line come up? It means more and more calcium carbonate will become dissolved, which means it threatens a lot of animals which actually builds this reef and all. This is one of the reasons why coral reefs are depleting in and around the world. Okay, because of the rise in saturation horizon. Now let's consider this this entire process on long time scales, say like 100,000 years and more. There is a natural balance maintained between uptake and release of carbon dioxide on Earth. Yes, there is this natural process. The carbon dioxide that is absorbed is released also, so that cycle exists. In the long term, there is there is a stability. There is no huge changes or anything. But on a shorter scale, say like 1,000 years and more, the ocean has an internal stabilizing feedback, linking the ocean carbon cycle to the underlying carbon-rich sediment known as carbonate compensation. Very important word. Please study this. Carbonate compensation. This is a short-term stabilization process. Okay, so how does this work? What is this carbon compensation? Basically, I will read through this. Try to understand. Let me read through this first and then I will explain. The upper layers of the ocean tend to be saturated with calcium carbonate, already mentioned. So little dissolution takes place in this region, whilst the deep ocean is undersaturated and carbonate readily dissolves. Correct? The first boundary between the two states is known as lysocline. Please remember this terminology. Lysocline. Okay? The depth at which dissolution strongly increases in the deep ocean. It's basically that horizon, saturation horizon. So that line is scientifically termed as lysocline. The depth at which dissolution strongly increases in the ocean, that is known as lysocline. The calcium carbonate in the form of dead shells sink to the seabed. Okay, if it is of a shallow water depth, the majority is buried in the sediment and trapped for a long time. But where the shells sink in deep water, nearly all the CaCO3 is dissolved, thereby not locking the carbon away for millions of years. Okay, so think about it. In the ocean, there is all kinds of topography. Okay, So earlier I said that in the deep cold waters, calcium carbonate concentration is very much undersaturated. Okay, those waters are very much undersaturated. So calcium carbonate will immediately dissolve. But in the shallow waters, it's not the case. It does not dissolve because of the over concentration of carbonate ions. Correct? So in the shallow waters, these shells will remain as shells and will get sedimented. So all the carbon dioxide will get locked away for a very, very long time because they are in the sediment form. But if they fall into deeper oceans and they readily dissolve in the ocean water, it does not get locked away because it is not forming sediments, which means it is still within the cycle. Get it? So that carbon dioxide does not get locked away and is very much still present in the earth. Clear? So the current increased rate of dissolution of atmospheric carbon dioxide into the ocean results in an imbalance in the carbonate compensation depth, the depth at which all carbonate is dissolved. As the pH of the ocean falls, it results in a shallowing of the lysocline and the CCD, thus exposing more of the shell trapped in the sediment to undersaturated conditions, causing them to dissolve. So basically, because of the more and more carbon dioxide concentrations on the atmosphere, this lysocline or that saturation horizon is becoming more and more shallow. I explained that in the previous slide. Correct. That saturation horizon is actually keep on coming up. What does this mean? This means that even those carbonate sediments that got locked away started to dissolve, thereby releasing more and more carbonate ions into the ocean, which means carbon dioxide is still very much in the cycle. All those locked away carbon dioxide has come back into the system, thereby facilitating ocean acidification. Did you understand that? More carbon dioxide in the atmosphere means the lysocline has come up, which means that all those sedimentary forms of carbon has also now come into the cycle, which was not supposed to come into the cycle, but because of this rise have came into the cycle and has contributed even more into the ocean acidification. Clear? So this process is also termed as upwelling. Okay, you have to understand what upwelling is. Upwelling is associated with a lot of terms, a lot of processes in the environment, especially regarding oceanography. So this is a common term that we see associated with, fishes. Okay, in the fisheries sector. Similarly, in eutrophication, etc., etc. How? I'm going to explain. This is the last slide for today. Okay, so surface coastal regions periodically experience upwelling events where deeper ocean waters circulate onto continental shelves and near shore areas. This is known as upwelling. Okay, in upwelling, what happens is, if this is the coast and this is the water, the deeper ocean water starts to come up. So what will happen if the deeper waters come up? The deeper ocean currents will bring up all the minerals and nutrients, etc., in the lower part of the ocean into the upper region. This is known as upwelling. Okay, and this exposes productive upper layer of the ocean to colder water containing more nutrients and more CO2. Earlier I told you the CO2 get dissolved, correct? The carbonate compounds will immediately get dissolved in the lower portions of the oceans, correct? I told you that beneath the isocline, the rate of dissolution is very, very high. It immediately gets dissolved. So all these dissolved carbon forms and the carbonate ions, along with all kinds of minerals, are all brought up during upwelling. And this will cause even more issues in the shallower regions. It will severely affect the productive shallow regions of oceans. Okay, as ocean acidification makes the upper oversaturated layer of the sea water shallower each year, these natural upwelling events will more often cause undersaturated water to well up and flow to the shore. So, ocean acidification keeps on making the upper layers more and more saturated. And this upwelling events brings the water from beneath, and it all the nutrients and the locked away carbon things, everything is brought up into the shallower region, thereby causing negative impacts on the aquatic ecosystem, such as coral reefs and all associated regions, especially in the towards the shores. Okay, we do not see this much in the mid of the oceans. We see this more in the continental shelves and all, near to the land region. Okay, so coastal marine organisms that forms shells are unaccustomed to such events, and periodic exposure to these significantly different conditions may affect these communities. So these coral reefs and all other oysters, etc., which are capable of producing these shells, they are not very much accustomed with such changes in the ecosystem. So this constant upwelling will hinder their life process and cause huge depletion in aquatic and marine ecosystems. Okay, so I know that today's chapter has been a bit, could be confusing. It was not lengthy, but the concepts were slightly confusing compared to the previous classes. Okay, I think especially regarding the ocean acidification area, things could be a little bit confusing. Don't worry about it. Read through the whole thing once again, and you will definitely understand the full process. Okay, you have heard my explanation, and it is still a bit confusing, I know, but once you read through this again, things will get more and more clear. Okay, so I will upload all these things in the Telegram channel straight away so that you can go through it once again. And that is it for today. We will, in the next class, we will study about ozone layer depletion, and then we will study regarding India's contribution to climate change and all in the upcoming classes. Okay, so please make sure to like this video and subscribe to my channel. Tomorrow there might not be class. Okay, I might not put any classes for tomorrow, so we will see again day after tomorrow. Until then, good night. Bye bye.